All right, class, let's go. This is day 3 of 4.1. We're almost there. I think right here, we're going to finish up here. So let me go back to what we've learned so far. Just real quick here, sketch. And so we remember making this table a long time ago, before Thanksgiving.
Yeah.
Okay, what we did is we used the ratios that we know, and then we did approximations for them, because we were trying to get to a X and Y correlation, right? And so, boom, we got it. There it is. We made all this happen, and then we went backwards. We're like, you know what? That's fine and dandy for us. Second, okay. But we're gonna go back to these values here. We're gonna use 0, we're gonna use pi over 2, we're gonna use pi, 3 pi over 2, and 2 pi. You know what? Okay, before we begin, I want to guys give you a visual of the unit circle going into a sine function, and actually the other ones as well. So that's what we're going to deal with today. So we're going to deal with graphing them. So, but first things first, here it is. Let's go with it here. We should. Desmos here. So here's, you guys ask me away if you need it. Okay. So the red line right here is the length away from 1, 0. The X is now the angle measurement that's made, or the length here. And then the height is just the height. So notice I'm plotting this point here with this point here. I'm just making them exactly the same height. And it's a plot, plot, plot. And then once we get to pi over 2, and we reach the height here, and we come back down, and we get to 0 right there. And then again, the height goes down to -1, back to 0. And then question is, does it keep on going? Absolutely. So if I extend this even further past 180 degrees, we can keep on going. So it doesn't allow me to go on the applet here. So this is almost at 360, just shy of 360. And then if this guy would allow me to drag it some more, we would go around the unit circle another time, but our height would go up and down again. So for sine, here's what we say for sine. Sine is, we call it a hill and a valley. Are you good? So you say, what's the graph for sine? Oh, it's a hill valley. That's what it is. See again? Wiggle. Okay, cool. I got it. Okay, so this is sine, guys. Let's go with now cosine. A little funky at first, because no, it's no longer the height. I think visually we like to see height here. So here's what we got. The cosine function. Da, 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 da. Okay, set up the same. Takes a little while to load. That's what I was trying to find it last time, and it took so much time to load. Sine, that was sine. Okay, now the cosine function, again, kind of looks a little bit interesting. When we do this here, it's this little measurement. It's from the origin up to this purple dot right here. No, let me see if I can. Oh yeah, get rid of the advertisement. This is cosine now. Last one was sine. Last one was just so the red dot right here, or the red value corresponds to the red value here, right? We are moving away from 1, 0, and as I move, this purple dot right here, this purple dot is getting lower and lower, up until the point that I get to pi over 2. Da, da, da. What happens at pi over 2? I'm back at the origin. Is that right? So I should get a value of 0. And then I keep on going. So then I go. Now notice I'm in the negative territory, right? So because the cosine value is actually the coordinate itself, right? So then I do that. And again, it goes down to -1 right here. Comes back up to a 0, and then again I think it's going to stop again, but there it is. It stops. We've completed one full rotation. We're good. There's your cosine. So real quick here, for us, it really is just a matter of how we normalize. So the cosine value starts at 1 this time, because And when we're right here, our point is actually 1, 0. We're good? So cosine value starts at 1, goes down to -1, comes back up to 1. So what do we say for cosine? It's called a hill-valley hill. We're good? So sine is just hill-valley, cosine is hill-valley hill. And it's this little big, humongous valley in the middle. Okay. Say again? We call it a cosine wave, absolutely. That's a cosine wave, the other one's a sine wave. Okay, so now let's get started. So let's graph it. So let's that's one thing. I was going to check whether we do tangent in 4.1. We do tangent in 4.1. Okay. So let's graph sine and cosine first. Let's kind of get used to these first, and then we'll jump to cosine. We've got about 15 minutes here. Ding, 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 ding. Maybe we should check something out real quickly. Okay, let's jam. So tangent is, tangent is pretty cool. Okay, learning how to graph these here. So cosine is a hill-valley hill, and let's graph it. So can you guys graph for me? So here's what we want to do. We want to graph a x and y coordinate system, and the important points that we want to put in is 0. We want to put in pi over 2, pi, 3 pi over 2, and 2 pi. So we are graphing like this now. Right here. No, on a sheet of paper. So we're going to go extend this out. We are going to graph y is equal to sine of x. Now a little bit more abstractly, not by a table, because we did it before by table. So what I do here, negative 2. This will be -2. Just gonna leave a little bit of space. So real quick, just so we begin here, we've kind of started 4.1 3 times. We're good. So if you want to kind of put notes in, if you want to actually say 4.1 basic graphs, take 3. So now we're officially starting. Yeah, so we can graph this real quick here. So manually graphing it was, you probably go up to down to -2, and we're going to start off like this. We're going to go all the way out to 2 pi first. Take half of that. So whatever length that you just made, take half of that, put a pi. Whatever length of that you made, take half of that. We're going to make that into 2 pi. And the way I do it, we'll do it later on. If this is pi over 2, this would be 2 pi over 2, and this middle one would be 3 pi over 2. Let's see, this is pi over 2, or 1 pi over 2, 2 pi over 2, 3 pi over 2, and then eventually 4 pi over 2, which is 2 pi. Perfect. Okay, so we're going to do that kind of thing a lot. What we're doing. Okay, sine curve. Ready? Starts off at 0. Reaches a max of 1 at pi over 2, goes back down to 0 at pi, goes down to a -1 at 3 pi over 2, comes back up to 0 at 2 pi. And can you graph a nice sound wave? So curve it up, just make sure it almost looks like a little parabola right at the 1 value here. It comes back down. And nice curve this way. One thing I don't want V shapes. It should be a nice kind of curve in and then curve out. Don't do V shape. Don't do like a corner and comes out again. Okay, now we do have to understand. We're going to put one little extra thing at the end. This is 1 full revolution. We're good. And so when we're going to be graphing these, we're going to just kind of. Sometimes we'll stop because it says graph 1 revolution for me. That's it, or graph 2 revolutions, and we stop there. But we should understand this real quick here. We're going to put little arrows right here, and we're going to put little arrows right here, just to tell us in our mind, like, yes, it does keep on going.
This is sine, right?
This is sine. Okay, so a few things we should note about it. And I'll have this. I'll set this down, and you guys give it to me here. So I need, for the sine curve that we just did, underneath it, just write this underneath. I need domain. I need range. I need something called amplitude. We'll do something called period. Zeros. And the even odd distinction. Oof. So. Let's check this. I'm looking at. This is just entered to it here, and then we'll work from there. Okay, so for domain, let's go back to this guy here. What is domain here? Is there any issues where we have breaks in our graph? No. I take a pencil, right, and I can graph this line all the way through, right, and keep on going. So domain is all real numbers. Cool. Range. I need the range. Yeah. Well, I mean, for the full set, it would just be so the range is what values of y affect the graph, or what values of y, if you were to slice horizontally, would hit the graph. So at -2, I don't think so, right? Because it doesn't hit the graph at -2. Yeah. So this graph starts off at -1. There's my hit right there. At +1, hit there, and anything above 1 does not work. So in this case, my range is -1 is the low point. High point is 1. Okay, now we look at something called amplitude. Amplitude we'll do a lot with it here. This is amplitude is half. Maximum versus minimum. Cool. So we go back over here. So what this means is the max value that we have is here. The minimum value we have is here. And the amplitude really is kind of like half of it here. So if I get the middle is right here. And the amplitude is just half. So from the middle ground, when it's in a sense right at 0 or right at its neutral spot, how much does it go up? Or how much does it go down? It's the same number. In this case, it is going to be 1. Absolutely. It goes up 1, it goes down 1. That's amplitude. If we want to do it 1/2. If we actually want to do it by formula, it would go like this. It'll go, the maximum value is 1.
So 1/2 is 1 + 1.
Yeah, minus the minimum value is -1.
Okay, yeah.
So that'll be half of 2, which is 1. Boom. Okay, period. Period just means how long does it take for the graph to start repeating itself? Yeah, so notice we started here. Once we got to 2 pi, we're going to have a repeat of what came before. So 2 pi is the period for sine. Zeros, when do zeros occur? Let's go back to sine here. So that 0 occurs at 0, at pi, 2 pi. Hey, I think I like this. Hold on, if it goes backwards, it would hit what? -pi. So let's make a little. Let's see, how do we do this here? 0 here at 1 pi, 2 pi, 3 pi, and forever. Is that right? Then on the flip side, negative pi, negative 2 pi, negative 3 pi. Those are all zeros. I have to account for all those zeros. And there's a special way we do it in mathematics, and here it is. Ready? It says all the zeros happen when x is equal to k pi. And then what we do is we define what k is. Sure. Go ahead.
I'm still trying to get down the definitions for all of them.
Oh, gotcha.
What's the definition of period? Yeah, and then the definition of the explicit definition of variable.
The repeat, when it starts to repeat itself.
It's not for a period.
For period, For range, it would be y values.
Well, can you be more specific?
Range
of the y value?
Range of y values, absolutely.
That's how high is it going, how low
Yeah, and then as long as there's no breaks underneath that.
And period is when it starts repeating, or is it just the whole
interval?
average? Yeah, okay.
Interval before repeating. I think we're going to have a day 4 of 4.1. Oh,
I guess this is
It was a lot more progress like the other two. The other ones, we were,
And I guess
she showed us a thing, and then we got really confused, and then we had breaks, so we had to do it all over again.
No, I'm glad we did though. Then real quick here, you guys talk to me. Dylan, ask me questions if you need to, okay? Even and odd functions, you guys remember those? Even functions like x, okay, from algebra.
I might want to tell you.
Yeah, I don't remember how you figure out. Oh, is that the shade? No, that's.
No, that's it.
What exactly is R zeros?
Zeros, x-intercepts. Perfect, yeah, please ask me the questions. That's why you guys are here. We're ready to learn, put things together here. So an even function is usually the common even function is x squared. And what we call by even function is the fact that if I fold it, I'm going to fold it right across the y-axis, and it's going to fold right on top of itself. An odd function exemplified by x cubed, that's an odd function.
You have to fold it into quarters.
Fold it into quarters. Yeah, you got to fold a y-axis and then an x-axis, then it folds on top of itself. So the sine coordinate, the graph itself, let's see what's happening. Yeah, this is an odd function. Okay. It is an odd function. Okay, now. Let's see, what's the other stuff with odd functions here? What happens with odd functions and even function, this is the definition, this is the connection to it, is notice if I have an x, a positive x, positive y, I also have a negative x, positive y. So notice what happens here. If this function was x squared, if I were to plug in a negative into my function, guess what happens? You still get positive. The negative does not affect, the input of the negative does not affect the output of the function. I could plug in negative or positive, who cares, right? Negative 2, positive 2 is still giving me 4. So the negative values don't affect the outcome at the end. Odd functions. Odd functions, yes, they do. Because I plug in a negative into here, negative cubed gets me, oh, look at this. I can still have my x cubed, that's fine. But then I have to push the little negative in front of it. We're good there. Or set it a different way here for the negatives. Negative of a negative x cubed will get me back to the original problem. So we'll start there next time on Friday. Okay, we're making progress. Just kidding that. Just kidding that slow.
We'll turn our test.